Hi, my name is Mr. Webster, 5th grade teacher at Maude Trevvett Elementary School, and welcome to my 5th grade science class. Y'all ready today?
Yeah.
All right. Today we're going to start off with a mixed pair share, okay? Remember, when that music starts, you are going to get up, you are going to walk around, you are going to be quiet. Then when that music stops, you are going to pair up, and after that, I'm going to ask you a question. When you are done, you are going to say thank you for sharing and do what?
High five.
High five. All right. Y'all ready? All right. Push in your chairs and let's get it. How can energy flowing through a circuit be used to do work? Go.
Well, if it goes through the circuit, it can go to the part where you need it to be used.
All right, good job. Let me see hands. Who wants to give it a shot? Who wants to share out loud? Marcus.
So like basically if like a charger is charging, when that energy flow, it charged the phone.
Good. So that energy from that electrical socket is coming out and is charging that phone. All right, great job. Great job. Everybody give Marcus 2 claps. Your next question today is, what is a conductor and an insulator? And talk about examples of both. Ready, set, go.
Okay, now I'll give you examples. Copper examples for conductors. Copper and any other metal. And water.
All right, bring it back to me in 5, 4, 3, 2, 1. Who wants to take a shot? What is a conductor, Mizan?
A conductor allows energy to flow through.
It allows electricity, energy to flow through. What is an insulator, Amani?
Insulator is something that doesn't allow energy to flow.
Okay, good job. Ronnie, what's the example of a conductor?
Copper penny.
Copper penny. What's the example of an insulator? Anna. Rubber. Cam. Conductor. Aluminum. Great. Insulator, Henry.
Wood.
Wood. Great job. Conductor, Sean.
Iron.
Iron. Great. Calvin, last one. Give me an insulator.
Wood.
We already said wood. Help them out, Marcus.
Dry air.
Dry air. Great job. All right. Everybody give yourselves 2 claps. All right. When you hear this one, you're going to go back to your seats when you hear the music. All right, next we go review our vocabulary words with the game of I Have, Who Has. You need to beat your time that you did yesterday, and then we will start our experiment, okay? Just grab one. It does not matter. All right, and I have 2. So who has the first card? All right, Alicia, go ahead.
I have the first.
Speak up, please.
Who has a complete path around the electricity that can flow? I have circuit. I have current.
Good.
Who has house and mirrors captive?
I have Mizan, who has an energy source with chemicals stored in paste form so they will not spill.
I have Dry Cell. Who has the best soccer player at Trevvett?
I have Martin, who has energy fueled by transfer electrons.
I have electricity.
Great job.
Who has a magnet made by passing an
I have
electric current?
electromagnet.
Great.
Who has the process of changing one form of energy to another?
I have energy transformation.
Great.
We have materials that do not allow electric current to pass through them.
I have open circuit.
Read yours again.
Who has materials that do not allow electric current to pass through them easily?
I have insulator. Who has the silent speedball champion?
I have Miss Brown. Who has the area around the poles of a magnet that stands out?
I have magnetic field. Who has the most energetic fifth grade teacher?
I have Miss Grisman. Who has the energy an object has because of its motion or position?
I have mechanical energy. Who does not allow electricity to flow through with the current?
Who has energy traveling in electromagnetic waves such as solar energy?
I have radiant energy.
Done.
Great job. All right. Great job. Great job. Give yourselves a round of applause. All right. Good, good. Now we're about to start our electromagnet. Okay, so put your cards down. Put your computers and notebooks on the floor. Girls, hair up if you can. Long sleeves up if you can. All right. Pencils on the floor too. Pencils on the floor. Everything should be on the floor. All right. So y'all been waiting for this day. Okay. So today we're going to talk about the strength of an electromagnet. What is an electromagnet? Can somebody tell me what an electromagnet is? Mira.
It is a magnet that can be turned off and on.
Okay, it's a magnet that could be turned off and on through what? Why can't it be turned off and on? What causes it to be able to be turned off and on? Something that you use every single day. The lights are it, the sockets. Sahar.
A switch.
Not a switch. Henry? Electricity, okay? That's what an electromagnet is, all right? The electro part is that electricity. That magnet part is just a magnet. You know what that is, okay? All right, our learning targets for today is I can plan and conduct an investigation to determine the strength of an electromagnet. You can construct a simple electromagnet using a dry cell, wire, nail, and other object containing iron. I can define a problem and design a solution that uses an electromagnet, and I can demonstrate and explain how the electromagnet works. All right? So this is what an electromagnet is. You have already told me, okay? Electricity can produce magnetism, okay? An electromagnet is a device that creates a magnetic field using electricity, as we know. When somebody rings your doorbell, a small electromagnet pulls a clapper against a bell, okay? A lot of y'all have those digital doorbells like Ring and stuff, so it might not do that, but like a real doorbell, okay? The doorbell that say ding dong, you know what I'm saying? Okay, cool. Junkyards use huge electromagnets to move large piles of scrap metal. They can even move cars, all right? So we're going to make a small one to move our fake cars, which are the paper clips. Does that make sense? Okay. So here are some more items that use electromagnets every single day. We have a refrigerator. We have a dryer. We have the computer, a vacuum cleaner, and speakers. All right, and this is something that we can use in a grand scheme of things. All right, grand scheme of things.
Rideau Metals Recycling in Mississauga, Ontario. This is where metals come to be sorted and recycled. This is a magnet grapple. It's a big machine that helps with the sorting. That big plate at the end of the arm is an electromagnet. That's Kyle. He's making it work. Kyle presses a button that sends electrocurrents to the magnet so he can pick up tons of metal. Then he can take it where it needs to go and stop the electrocurrents to drop it.
First, let's talk about this with your table, okay? How can we determine the strength of an electromagnet? Go. Talk with me about your table. Ronnie and Anna, Sahar, Cam, and Calvin, stand up and go travel. All right, stand up and go travel. Talk to this table about what your table just talked about. All right? Go ahead. All right, so one person, tell me what the people just told you that just came to your table. Mizan, what did Calvin tell you?
He said it's however many times the wire coils around the nail.
Good job. So who else agrees with Mizan and Calvin? All right, great job, okay? So y'all can go back to your seats, the people that traveled, thank you. And we need to make sure we have all our materials. So look at your table. All right, do you have a nail? I actually really gave you a screw. These are called screws, okay? I did not want to give you a sharp object. So do you have a screw? Yes. Okay, everybody grab your screw and put it in front of you. Do you have a battery? Yes. All right, what's another name for a battery? Dry cell. Great job. Grab your dry cell. All right, everybody needs a rubber band. Is a rubber band a conductor or an insulator? Insulator. Great job. All right. Copper wire. Everybody grab that copper wire. All right. Is this an insulator or conductor? Conductor. Great job. And then just leave your stack of paper clips in the middle of the desk because after we build this, y'all are going to compete to see how much yours can pick up. Does that make sense? Okay. So this right here. It's the electromagnet, okay? I have my battery, I have my rubber band, I have my copper wire, and my nail. The first step is you have to get this copper wire wrapped around that nail as many times as you can, okay? Because that is what's going to start creating that magnetic field. All right, after that, rubber band around your dry cell, and then attach it, and then you should be able to start picking up. You can whisper, you can help each other. Make sure that you don't start at the end, okay? You want to start more in the middle because this end is going to have to touch both sides, and when you hold it, that's when you can pick up your paper clips. Does that make sense? All right, so start collaborating, help each other, and start building this, all right? Good, and you just go keep on wrapping that around, okay?
I don't think I'm doing this hard. That's what I'm saying. This is hard. This is hard to do.
All right, you're going to have to use some strength and wrap it around.
Oh, slippery.
I'm struggling really hard right now.
Look. Hold one side, look.
I just got it. Me too.
Okay?
I love this part.
Hey guys, you're going to hold one side, and then you just wrap it around like that. That's the easiest way to do it. Does that make sense?
Oh yeah, this is easy.
Okay. Mizan almost has it done, so she is going to be my helper. All right, after Mizan finish hers, she's going to go around and she is going to help. Yep. And then you're going to put this in here. Like this. Hold that side. Okay. And then put that side over there. Bryce has it. Great job. Great job. Mizan has hers over here. So you're going to have to do the side of it. There you go. There you go, Mizan. Keep on going. Grab some more. Great job, Bryce.
Can you help me?
You don't have to use the rubber band.
It's the copper wire.
Yeah.
I want to. I don't want to burn my fingers.
Because you can. This.
Did I do it right?
I just burned myself.
All right. So then you can just hold it with your fingers, okay?
Yeah, it does get hot.
There you go. All right. No problem. Once you have it built, now we can start going with the investigation. The investigation is not just picking up the paper clips. The investigation is how many times do we coil it around to pick up more paper clips? All right, so once you get it to work, now start playing with how many coils do you have around the screw.
They're actually scared.
Because we gotta be tight. There you go. All right, so look, hold it. So hold it at the ends.
The wire's hot.
All right. There you go. And now
I'm gonna try to change where my rubber band is.
I got 6. How many coils did you get?
good. Make sure you write down how many coils you have and how many paper clips.
Okay, now it's not working.
There you go.
Sahar said, if it's just touching the insulator, nothing is going to happen. You have to make sure that it's touching that battery because you want all of your conductors to work together. If it's touching the insulator too much, then it's not going to work. So Anna, pick up all those paper clips again. All right, and hold it up so the whole class can see. All right. So as you see, she's not even holding the size of it. She has wrapped that rubber band around where it's already tight enough, and now it's picking up the paper clips, okay? So right now she has about 4 fake cars, okay? Because remember, our paper clips are cars, okay? So Anna, what I want you to do is write down how many times you wrap that copper wire around your screw, and then how many paper clips you have. All right, great job, Zoe. Once again, can somebody remind me what a independent variable is? What is an independent variable? Yes. Something that I change. Something that I change. Everybody say that. Something that I change. All right? Great. So independent variable is something that I change. What did we change in this experiment? How many times we wrap that around the nail? Great job. So what's the dependent variable? What does that mean?
Something that we don't change.
Well, let's change that wording a little bit. You're correct, but let's change it a little bit. Help her out, Ronnie.
The result?
The result. But what's another word that we can use? Do we have any other words? So the result.
The product of your independent variable.
Okay, let's go with that. Let's build off of that. Okay, so the dependent variable is basically something that happens depending on what? The independent variable. Okay, so it depends on what I change. So what's the dependent variable here? What do you think? Like, what's the end goal? What's the end goal? Somebody other than Mizan. What's the end goal? Cam, what's the end goal?
The end goal?
Yeah, what's the end goal?
The goal is to pick up a bunch of paper clips.
That's the dependent variable. Okay, that's the dependent variable. How many paper clips were I able to pick up? That's the dependent variable. And what's constants? What does constants mean?
Stay the same.
They stay the same. They stay the same. What stayed the same in this experiment? The dry cell or the battery. What else? The rubber band, the screw. It's the same wire. It's the same paper clips. Does that make sense? So that's all of our constants. All right, great job. Okay. So who decided? Who only had 3 coils around their wire? Raise your hand if you had only 3. What about 7? Do anybody have more than 10? Anybody wrapped in more than 10? Okay. So the 7s. How many paper clips were you able to pick up?
6.
You got 11 with 7, 12, 6, 3, 3. Why do you think it's a difference? Why is it a difference?
How tight you did it?
How tight you did it? What else?
How many
Yes, Mira.
how like the wires touching the battery?
Okay, how tight the wire is touching the battery. Okay, so let's increase the number of coils we have. Okay, everybody, let's at least try to get 10 around the nail. Let everybody do 10. Everybody do 10. Great job, great job. Now that we did 10, what's the numbers now? What's the numbers now? We have 4, 3, what else?
14.
We have 14, we have 8. What do we have over here, girls?
I can't.
You have 5. How many coils can y'all do? Y'all got 7 and 8, and y'all had 10. Okay, good.
Mine's not.
All right. So based off of this, what's the conclusion that we could come up with? What's the conclusion? Like, what can we say about electromagnets? What can we say about electromagnets when it comes to the number of coils? Alicia, you want to take a shot at it? All right, hold up. You got to speak up so everybody can hear you.
The more you like put it on the stream or something, it goes like more intensified because more
Okay, so she said the more times you coil it around the screw, the heat intensifies. But what else can we talk about? I like where she said the more coils we have, but the more coils we have, what happens with the paper clips? The more paper clips we get to pick up. Okay, so that's the whole conclusion with this. When we talk about electromagnets, boys and girls, we are talking about how many paper clips we can pick up. You're going to see this again and again and again, okay? Thank you so much for joining our 5th grade class and enjoying our electromagnet experiment. Go Tigers!